Find the value of tan inverse of 2 sine of 2 cos inverse root 3 upon 2. So we can write tan inverse of 2 sine of 2 cos inverse of root 3 by 2. Since we know that cos pi by 6 is equal to root 3 by 2. So we can write cos inverse root 3 by 2 is equal to pi by 6. So we can write 2 into pi by 6, which is equal to tan inverse of 2 sine of pi by 3. And we know sine pi by 3 value is root 3 by 2. So we can write here 2 gets cancelled. So tan inverse of root 3. And we know that tan pi by 3 is equal to root 3. So we can write tan inverse of root 3 is equal to pi by 3. So we can give the answer here pi by 3. So the value of tan inverse of 2 sine of 2 cos inverse root 3 by 2 is pi by 3. Show that the function f defined by f of x is equal to x minus 1 times e power x plus 1 is an increasing function for all x is greater than 0. So here it's given x is greater than 0, and we need to show that the function f is increasing function. The condition is f dash of x is greater than 0. So let us find its derivative. Differentiate with respect to x. So we have f dash of x is equal to x minus 1 into differentiation of e power x is e power x plus e power x into differentiation of x minus 1 is 1 plus differentiation of 1 is 0 by using UV rule. So we can write f dash of x is equal to x into e power x minus e power x plus e power x. That is f dash of x is equal to x into e power x, and since we know that x is e power x is greater than 0, e power x is greater than 0, and since x is also positive, so x into e power x is also positive, and hence we can say this f dash of x is greater than 0, and hence we can say that f is, as per the condition, whenever the derivative is greater than 0, f is an increasing function. Okay. Find the point of maximum of the function f of x is equal to sin x plus root 3 cos x in the interval 0 to pi. So to get the minimum or maximum value, we need to differentiate and equate to 0. So let's differentiate. F dash of x is equal to cos x minus root 3 sin x. For minimum or maximum value, f dash of x is equal to 0. So we can write cos x minus root 3 sin x is equal to 0, or root 3 sin x is equal to cos x, or tan x is equal to 1 by root 3. In the interval 0 to pi, we can give the value as x is equal to pi by 6, because tan pi by 6 value is 1 by root 3. And now, so in the interval 0 to pi, the closed interval, so we may consider the values as x is equal to 0, pi by 6 and pi. Let us check at these values. F of 0 is equal to sine 0 plus root 3 into cos 0. that is 0 plus root 3 into 1, which is equal to root 3, and f of pi by 6 is equal to sine pi by 6 plus root 3 cos pi by 6, that is 1 by 2 plus root 3 into root 3 by 2, which is 1 plus 3, 4 by 2, that is 2, and f of pi is equal to sine pi plus root 3 into cos pi. Sine pi value is 0 plus root 3 into cos pi value is minus 1, so minus root 3. So here we can observe that among these three, the maximum value obtained is 2 at x is equal to pi by 4. So we can conclude that at x is equal to pi by 6, the maximum value is equal to maximum value of the function f is 2. So we can conclude the point of maximum is nothing but the point is x is equal to pi by 6. So this is the point. At this point, the maximum value gives, that is 2. So pi by 6 is the answer.
The volume of a sphere is increasing at the rate of 3 cubic centimeter per second. Find the rate of increase of its surface area when the radius is 2 centimeter. So given let us consider, let V be the volume of sphere whose radius is r. So we have V is equal to 4 by 3 pi r cube, and it's given that it's a dV by dt is equal to 3 cubic centimeter per second, and we need to find the rate of increase of its surface area. And surface area, let us consider A be the surface area, so which implies A is equal to 4 pi r square, and we need to find dA by dt at r is equal to 2. Okay, now let us consider volume V is equal to 4 by 3 pi r cube, differentiating with respect to t. So we have dV by dt is equal to 4 by 3 pi is constant, and r cube differentiation is 3 r square dr by dt. So dV by dt is given 3 cubic centimeter per second. So we can write 3 is equal to 4 by 3 pi into 3 r square dr by dt. That is 4 9 by 4 pi or into 1 by 3 r square is equal to dr by dt, or we can write 3 by 4 pi r square is equal to dr by dt. Now let us consider surface area. A is equal to 4 pi r square, and again differentiating with respect to t. So we get dA by dt is equal to 4 pi into r square differentiation 2r dr by dt. So dA by dt is equal to 4 to the 8 pi into r into dr by dt value, let us substitute here, into 3 by 4 pi r square. So which is equal to dA by dt is equal to 3 to the 6 upon r, and when r is equal to 2, dA by dt when r is equal to 2, which is equal to 6 upon 2, which is 3. Since it is a surface area, we can say the rate of change, the rate of increase of its surface area is 3 centimeter square per second. The answer we can consider 3 centimeter square per second.
Find the integral of the function 1 upon root of x square plus 2x plus 2 dx. So we can write this as integral 1 by root of x square plus 2x plus 1 dx, which is integral 1 by root of x square plus 2x plus 1 is x plus 1 whole square plus 1, we can write it as 1 square dx. Let us substitute or put x plus 1 is equal to t. So differentiating with respect to x, we have dx is equal to dt. So we can write integral 1 by root of x plus 1 is t square plus 1 square dt. And we know that integral 1 by root of x square plus a square dx is equal to log mod of x plus root of x square plus a square plus c. So we can write here, which is equal to log mod of x plus, that is t, plus root of t square plus 1 square, that is 1, plus c. Substituting back t is equal to x plus 1, so we can write log mod of x plus 1 plus root of x plus 1 whole square plus 1 plus c. X plus 1 whole square plus 1 is nothing but x square plus 2x plus 2, so we can write log mod of x plus 1 plus root of x square plus 2x plus 2 plus c is the answer.
Evaluate integral e power x into 1 plus sin x upon 1 plus cos x dx. So we know that 1 plus sin x is, we can write sin square x by 2 plus cos square x by 2 plus sin x formula is 2 sin x by 2 cos x by 2, which is equal to sin x by 2 plus cos x by 2 whole square. And similarly, the denominator 1 plus cos x we can write 1 plus 2 cos square x by 2 minus 1. So 1 plus cos x is 2 cos square x by 2. So let us write here e power x times sin x by 2 plus cos x by 2 whole square divided by 2 cos square x by 2. Now we can write integral e power x into e power x upon 2 into sin x by 2 plus cos x by 2 divided by cos x by 2 the whole square dx, which is equal to 1 by 2 integral e power x into sin x by 2 by cos x by 2 is tan x by 2 and cos x by 2 plus cos x by 2 is 1 whole square to dx. We can simplify here 1 by 2 integral e power x into tan x by 2 plus 1 whole square is tan square x by 2 plus 1 plus 2 into tan x by 2 dx. So which is equal to 1 by 2 times integral e power x into, we know 1 plus tan square theta is secant square theta. We can write secant square x by 2 plus 2 times tan x by 2 dx. And if we can consider f of x is equal to tan x by 2, then f dash of x is equal to differentiation of tan is secant square x by 2 into differentiation of x by 2 is 1 by 2. So we can write, or you can take 2 common here, 1 by 2 into 2 taken common, we'll get e power x into 1 by 2 secant square x by 2 plus tan x by 2 dx. So we can write e power x into tan x by 2 is your f, and this is a differentiation of f, that is f dash. E power x into f of x plus f dash of x, we have the property which is equal to e power x into f of x plus integral constant c. So we can give the answer e power x into the function f is nothing but tan x by 2. So e power x into tan x by 2 plus integral constant c is the answer. Using integration, find the area under the curve y is equal to 2 root x between x is equal to 0 and x is equal to 1. So let us check here, y is equal to 2 root x, which implies y square is equal to 4x. We know that y square is equal to 4x is a parabola open towards the positive direction of x-axis. But since it is given y is equal to 2 root x, so we need to consider the y value to be positive. So we'll not consider negative side. So we can just consider this from x is equal to 0 to 1. Only the portion in the positive side. So 0 to 1, the required area is equal to integral 0 to 1 y dx, because this is the function y is equal to f of x, that is 0 to 1 2 root x dx, 2 times integral 0 to 1 root x dx, which is 2 times integration of root x is x to the power of 3 by 2 divided by 3 by 2 over the limits 0 to 1, or we can write 2 into 2 by 3 into x to the power of 3 by 2 over the limits 0 to 1, which is 4 by 3 times of x power 3 by 2, that is 1 minus 0. So we can say the area is area under the curve included between x is equal to 0 and 1 is 4 by 3 square units.